Yes, this is Unit 17, Lesson 3. Once again, as I've told y'all before, if you think you're going to have any questions about any of this, get you a piece of paper and a pencil or something to write it down with so that you can bring it and ask it tomorrow before we start any work. Okay, this is rotations in a plane. Okay, a rotation of a point or an object is the turning of that point or object around a central point and through a specified angle. So if we diagram it, it's going to look something like this. In this case, what they're actually doing is they're rotating a line segment. So that's how they got to this point. So you had this point, it rotated up here to P, but C was the center of rotation. Okay, the central point is known as the point of rotation that we just talked about. The angle through which the object is rotated is known as the angle of rotation. Okay, and the next thing here is the transformations of an object that produce an object that is congruent to its original self, as we talked before, are called rigid motions. Sometimes you'll hear these called isometries, and in this case a rotation is a rigid motion because you're going to end up with exactly the same object again. Okay, which one or ones of the following choices, A through D, represent possible counterclockwise rotations of 90 degrees, 180 degrees, or 270 degrees of this figure about the origin? To help see the answers, you might want to rotate the page in your hand through these different angles. Okay, so here's the original figure, which is just looks like a line with a segment on it, which is, I guess, a small angle of some sort. So which ones of these could actually be rotations of that? Okay? So as you can see, there's various different things. So if you rotate it, you should end up with the same object whenever you rotate it. Okay? So as you can see here, A and D are the two that end up with the same object after you rotate it. A is rotated through 90 degrees, and that's going counterclockwise, which is what the CCW stands for. CW is clockwise, and that usually causes problems when you're talking about it because of the angles. Okay, D is a rotation through 180 degrees. Okay, which one of the following choices, A through D, represent possible counterclockwise rotations of this figure? Okay, in this case they're rotating around the point 2, 0. So you need to look at the point 2, 0 when you rotate it. Okay, as you can see here, A is the only one that's going to actually be the same distance away from 2, 0 all the way through this and still maintain the orientation that it had originally. Okay? Right, example 3, they want us to plot the point 2, 1 and then find its new position P prime after it's rotated 90 degrees counterclockwise around the origin. So here's 2, 1. Okay, if we rotate it counterclockwise, it's going to go this way and it's going to end up here at 1, 2, or negative 1, 2. Okay? Okay, from example 3, a rule can be developed for rotating the point 90 degrees counterclockwise, and that's simply that xy becomes negative yx. Okay, example 4, they want us to plot the point negative 3, 1 and then find its new position P prime after rotating 90 degrees counterclockwise around the origin. Okay, so here's P, it's at negative 3, 1. And they want us to go 90 degrees this way, so that's going to give us what? If I can get, there we go. Okay, So just like we did a while ago, you're going to see that the x part became the y part, but it changed the sign of that, and the y part became the x part. Okay, from example 4, a rule can be developed for rotating a point 90 degrees clockwise, and that's simply this, that the y becomes the x, and the x becomes negative y, or the negative x becomes y. Okay, so for a rotation of 180 degrees clockwise, you get xy gives you negative x, negative y, and for a rotation of 270 degrees clockwise, you get xy gives you negative y x, and so on and so forth. Okay, these rules are sometimes easy to confuse, so here is a rule that is for any angle of rotation around the origin. X gives you x cosine A minus y sine A, and y gives you x sine A plus y cosine A, where the positive angles A rotate the point in a counterclockwise direction. Okay, it's very important that you remember that it's in counterclockwise, because if it's clockwise, to get the angle A properly, you have to subtract the angle from 360. Okay, syntax for the rotation of a point. Okay, what you have here is it's got a capital R. This means it's going to be rotated, and you notice that you have the AB, comma, and then a capital A, meaning the angle, and then the P means that that's the point that you want to be rotated. And this also means that it's always counterclockwise in this notation. Okay, rotation A, sometimes they'll flip the A first and put the XY afterwards, means to rotate the point XY through A degrees counterclockwise. Okay, if P is located at 5, negative 2, they want to find P prime, where P prime is equal to the rotation around the origin, 0, 0, and it's at a 30-degree rotation. Okay, so here's what we have. First thing is P prime of x. The x coordinate is going to be given by 5 cosine 30 minus negative 2 sine 30, which gives you approximately 533, 5.33, and you can put this in the calculator exactly like it's written. Okay, P prime of y, the y coordinate is going to be 5 sine 30 plus negative 2 cosine 30 is approximately 0.77. So the coordinates of P prime are going to be 5.33, comma, 0.77. Okay, example 6, they have a triangle ABC. It's rotated 180 degrees about the origin. What are the coordinates of B prime? Okay, so here's B prime. So if it's going 180 degrees, it's going to end up down here in the 3rd quadrant. It will have exactly the same coordinates as what B does, except it's going to be the negative of that. So the rule says take the x and y, just put negatives in front of them. So it says B's at 4, 7. B prime will be at negative 4, negative 7. Okay, equivalent rotations. This is something you need to know. A rotation of 360 degrees in either direction places the new object exactly on top of the original object. A rotation of 270 degrees clockwise is equivalent to 90 degrees counterclockwise. And you get this by subtracting the 270 from 360. Okay, so anytime they give you any kind of rotation, if it's not convenient for what you're wanting to do, you can switch it to the other. Okay, so a rotation of 270 degrees counterclockwise is equivalent to 90 degrees clockwise. Okay, these are things that you need to know. Like I said, the thing that you can do here is simply take, if they give you a clockwise one, you can always subtract it from 360 and use that angle, and it'll be the same as what you were doing before, whether it's 90 degrees or 270 or anything else. Okay, if you have any questions, make sure you make a note of it, bring it to class, ask the questions tomorrow, and I'll be glad to ask. answer them before we start. Thank you very much. Goodbye.